Hello guys, and welcome back to our YouTube channel. In this video we are going to learn about the transpose of a matrix. So by the end of this video you will know how to transpose any matrix, understand special cases, and verify important properties. Okay, so let us start. Now if we have a matrix, let's say A is equal to Aij, then the transpose of this matrix A can be written as A to the power T. So if you want to write A transpose, you just write A to the power T. So how do we find the transpose of a matrix? To find the transpose of a matrix, we simply interchange the rows and columns. That means the element in the I row and the j column of A becomes the element in the j row and I column of A to the power T. Okay, so let me just say what I mean by that. So if you have A, if this is our matrix, then the transpose A to the power T is simply J and I. So we have interchanged the rows and the column. So this is the row in this first matrix and this is the column. So if we want to find the transpose, then the row will become the columns and the columns will become the rows. As simple as that. Okay, so let's take an example. So if you have a matrix 1, 2, 3, 4, 5, 6. So first, what is the order of this matrix? Remember, the order of the matrix is simply row by column. So let us count the number of rows. We have 1 and 2. So we have 2 rows and how many columns? Let's count. 1, 2, 3. So we have 3 columns. So our order is a 2 by 3. Okay, so if we want to find the transpose of this matrix, then the first row, that is 1, 2, and 3, this first row will become the column, will become the first column of this our transpose that we are looking for. This first row will become the first column and the second row will become the second column. So we are just interchanging them. So as I said, this first row becomes the first column of this matrix. So we have 1, 2, and 3. And then this second row, 4, 5, 6, becomes the second column of our transpose matrix. So that is 4, 5, and 6. So that is all. That is the transpose of this matrix. So the rows becomes the columns and the columns becomes the rows. So here, this column 1, 4 has become the first row here. This column 2, 5 has become the second row, and this column 3, 6 has become the third column of that transpose matrix. Okay, so let us try another example. Let's say we have B. Let's say B is equal to 2 minus 1, 0, 3, 4, 5, minus 2, 1, 3. So the first thing, what is the order of this matrix? The order is the number of rows times the number of columns. So let's count our rows. As we can clearly see, we have 3 rows and we have 3 columns. So that is the first step. So we have a 3 by 3 matrix. So if we want to find the transpose of that matrix B. Remember, to write it is just B to the power T. That tells us that it is a transpose. So to find the transpose of that matrix, the first row becomes the first column and the second row becomes the second column. And here, since we have a third row, then the third row will also become the third column. So let me show you how it is done. So the first row becomes the first column of our transpose matrix. So we are going to have 2 minus 1, 0. The second row of our original matrix becomes the second column of our transpose matrix. So that gives us 3, 4, and 5. As easy as that. The third row becomes the third column of our transpose matrix. So we have minus 2, we have 1, and we have 3. That is all for that. So if we had a fourth row, then it will also become a fourth column. So it's not something difficult. It's very easy as that. Okay, so that is that, to write the transpose of that matrix. Okay, so now let's go to special cases of matrices, of this transpose matrix, because there are some special cases when it concerns transpose matrix. So now let's look at the special types. We have the first one, which is a symmetric matrix. Sorry, this is not X, this is C. A symmetric matrix. So a matrix is symmetric if the transpose is equal to the original matrix. So like this case that we had for B and B transpose, the matrix will be symmetric if our B was the same as our B transpose. Okay, so let's have an example. Let's say we have C is equal to 1, 2, 2, 3. So if we want to have the transpose C to the power T, C transpose, if we want to have C transpose, remember, to find the transpose of a matrix, the rows becomes the columns and the columns becomes the rows. So like this case, the first row becomes the first column of our transpose matrix. So here our first row was 1, 2. So the first column of this transpose matrix will be 1, 2. Now in this case, the second row becomes the second column of our transpose matrix. So we had 2, 3. So here will be 2, 3. And as we can clearly see, our original matrix is the same as our transpose matrix. That means this matrix is a symmetric matrix. Okay, that's for the first type. Now the second type, we have a skew symmetric matrix. A skew symmetric matrix. Now a matrix is skew symmetric if the transpose is equal to minus the original matrix we had. That means if you transpose it, every element flips the sign. So if the element was positive, then it will become negative. If it was negative, it will become positive. Let's take an example. Let's say we have a matrix D. It is 0, minus 2, 2, 0. So let's find the transpose of this matrix. Remember, the first row will become the first column of the transpose matrix, the second row of the original matrix will become the second column of the transpose matrix. Okay, so the first row here is 0 minus 2. So it becomes the first column of our transpose matrix. So that is 0 minus 2. And the second row will become the second column of our transpose matrix. So the second row we had 2, 0. So it becomes 2, 0. Now let's see. This is the same as minus the original matrix. Let's see. This first element 0 and this first element here 0. 0 is, it does not change, the sign does not change. So we have 0 and we have 0 here. Let's take this one. Minus 2 was the original matrix, but here we have 2. So the sign has changed. Here we have only 2. Here we had 2. Here we had minus 2. So the sign changed. And here we have 0. So 0 does not change. So it remains 0. So this, the transpose of this original matrix is the same as the negative of the original matrix. Okay, so symmetric matrices stay the same after the transpose, but screw symmetric matrices, the sign changes. So that's what you need to know for that. And there are some properties of transpose matrix. We have some properties. So now we have properties of transpose. So the transpose has some powerful properties. These are things that you need to know. So let's verify them with examples. Let's have the first property. So the first property is a double transpose. So this property says if you transpose twice, then you will come back to the original matrix. So it is like this. If you take the transpose of a matrix and you take the transpose of that matrix, then it gives you back the original matrix. Now let us see that. Let's have a matrix A, which is 1, 2, 3, and 4. So the transpose of this matrix, the first row becomes the first column, that is 1 and 2. The second row becomes the second column, which is 3 and 4. So that is a transpose. So this property says if I transpose this again, then I would have the original matrix. So let's see. If I want to take the transpose of that matrix, then remember the row becomes the column. So we have 1, 3. The rows becomes the columns. So we have 2, 4. Now that is it. As you can see, we have obtained the original matrix. So this proves that if you transpose twice, then you come back to the original matrix. Okay, so that was the first property of transpose. Let's take the second property, which is the addition property. So this property says if I have A plus B and I take the transpose, then it is the same as A transpose plus B transpose. Now let's check that. Let's have a matrix A, which is 1, 2, 3, and 4. Let's have another matrix B, which is 0, 5, 6, and 7. So let's check these properties. So let's take the left hand side. Let's start with the left hand side, which is A plus B transpose. Okay, so first thing, let's have A plus B. What is A plus B? You add their corresponding entries. So we have 1 plus 0, 2 plus 5, 3 plus 6, and 7 plus 4. So this gives 1, 7, 9, and 11. So that is A plus B. So now let's take the transpose of this matrix. So the rows becomes the columns and the columns becomes the rows. So here the first row becomes the first column of our transpose matrix, that is 1 and 7. The second row becomes the second column of our transpose matrix, so that is 9, 11. Okay, so that is what we have. Now let's take the right hand side. The right hand side is A transpose plus B transpose. So let's take A transpose. The first row becomes the first column, 1 and 2. The second row becomes the second column, 3 and 4. Let's take B transpose. The first row becomes the first column. The second row becomes the second column for our transpose matrix. Okay, so now let us add A transpose plus B transpose. So we are adding corresponding entries. So we have 1 plus 0, 3 plus 6, 2 plus 5, and 7 plus 4. So A transpose plus B transpose gives us, this is 1, 9, 7, and 11. As we can see, A plus B, all that transpose is the same as A transpose plus B transpose. So that is the second property. Now let's go to the third property. The third property is scalar multiplication. So this property says if we have a scalar and we multiply it by a matrix and then we take the transpose, it is the same as the scalar multiplied by the transpose of that matrix. Now let us have an example again. Let's have A equal to 1, 2, 0, 3, and we have B equal to 4, 1, 2, 5. Okay, so if, B is not needed. So if we have a scalar of, let's say, 2, so let's see. Let's take the left hand side, which is the scalar multiplied by the matrix alone, and then we take the transpose. So the scalar is 2, so we are going to have 2A, and then we take the transpose. So let's have 2A first. It is 2 times the whole matrix. So remember, scalar multiplication, we multiply the scalar by every element in the matrix. So this gives us 2, 4, 0, and 6. Okay, so now let's take the transpose of that matrix. Let's take 2A, all that transpose. So the row becomes the column. The first row becomes the first column, 2, 4. And the second row becomes the second column, 0, 6. Okay, so we have that. Now let's take the right hand side, that is the scalar times the transpose. So now let's take the transpose of A alone. So the row becomes the columns. So we have 1, 2, and we have 0, 3. Now let's take 2 times the A transpose. So this gives us 2 times every element in the matrix. So that is 2, 0, 4, 6. As you can clearly see, these two are equal. So that proves that property. Now let's have the last property, which is the fourth property. This is the product rule. This property says A times B, all that transpose, is the same as B transpose times A transpose. So in this property, the transpose reverses the order of multiplication. So let's have A equal to 1, 2, 0, 3, and we have B equal to 4, 1, 2, 5. So let's take the left hand side, which is this. So let's have AB first. So multiplication, the row multiplies by the columns. So here we have 1 times 4 plus 2 times 2. That gives the first element. We have 1 times 1 plus 2 times 5. That is second. 0 times 4 plus 3 times 2. And then we have 0 times 1 plus 3 times 5. Okay, so let's simplify. 1 times 4, that is 4 plus 4. Here we have 0 plus 6. Here we have 1 plus 10. And we have 0 plus 15. So this gives this 8, 11, 6, and 15. So let's take the transpose. The row becomes the column. So 8, 11, 6, 15. Now let's see whether it's the same as the right hand side. So the right hand side is B transpose times A transpose. So now let's take B transpose alone. What is B transpose? Simply 4, 1, 2, 5. And what is A transpose? It is 1, 2, 0, 3. Okay, so now let's multiply and see whether it is the same. So we have B transpose times A transpose. So the rows multiplies the columns. So we have 4 times 1 plus 2 times 2. That's the first element. We have 4 times 0 plus 2 times 3. Here we have 1 times 1 plus 5 times 2. Here we have 1 times 0 plus 5 times 3. Sorry, this is 5 times 3. So this is 4 plus 4, 1 plus 10, 0 plus 6, and 0 plus 15. So what does this give? It gives 8, 6, 11, 15. Now let us check. This is the same as this. So that tells us that the property proves. So that is all for the properties. Remember, when you want to transpose a matrix, the row becomes the columns and the columns becomes the rows. So that's all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.